if I call getNextNode on D, it'll be null. So we have to be like, hey, wait a second. Temp could be null, and I'm just going to put this up here because I might have to reference it later. So we have to make sure temp isn't null, because we could run outside of the bounds of the list. Okay. Okay, now that there's potentially two ways we could have jumped outside of here, if we had reached this condition or if we had reached this condition. So we have to do a quick check to see if we haven't reached the bad condition. So if temp is null, that means we're trying to add something outside, and you can vary if you want to say add it to the end of the list, or if you just want to return false, we're going to return false here. Okay, so now we know that we've taken care of any other case that could happen. We could just go ahead and add it to the list. So our new node, we're going to set its next node to, and remember, we're going to set it to temp.getNextNode, and temp, we're going to set next node to new node. Okay, let's see if I can go through this. So if you remember, new node is the one we just kind of added in, and temp is going to be the one basically before it. Or yeah, okay. So we're setting the reference to the next node of new node to temp's next reference. So say C is temp. We're setting this new thing, maybe F. So now F is going to reference D, and C is now going to point to F with this temp set next node. So we pretty much just added F in here at that position. Okay, I like this here. This actually helps make things a little bit more easy to understand. And okay, so we added successfully, return true. Okay, and remember we had this if statement all the way up here. We need an else, return false, boom. And we are done our add. Congratulations, this was one of the tough ones, I think. Okay, so this is all good. If you want to still don't understand this, you can pause the video, rewind, go over it, but this is all done. So let's go ahead and shrink this down so we have more room that we can see. Now remember when I said that we shouldn't write anything in here yet till we finish this one? Well, guess what? We can just use the functionality of that add in this add. So we can just set this to add, and then since we're going to be since this adds it to the end of the list, we can just do add it to get length plus 1, so we're adding it to the next position, and then we just pass it in this object. I'm gonna have to cough again, excuse me. Pause the video right there so you wouldn't hear me. But okay. And this is another one we still have to write. Right now I'll just return 0 so it doesn't yell at us. Now this also returns a bool, and remember this returns a bool, so we can just do this. Boom. Return add get length. Okay, that one's done. Now that was really easy, right? Okay. I guess we should probably fill out this is empty since it's kind of been sitting there. And remember we have this head node, and remember it's null if it's empty. Alrighty then. You know what that means. Return head node equals null. That's all we have to do. We have to just check to see if this head node equals null, then it's true, so we return true, it's empty. If the head node doesn't equal null, false, return false, it isn't empty. Alright. And since we did is empty, let's see, is full. And this is just going to return. I don't even know why we need this. It's just something that every linked list should probably have. Okay. So we've done 4 methods. Awesome. We've actually done one big one. Okay. So we've done add, is full, is empty, and add. Now, what should we do? Should we do get length, or let's do one of the other difficult ones? So let's do remove. And remove we're going to be giving it a position, and we're going to want the object of the node we removed. So we're going to remove one of these, but we want this stuff to remove, because hey, we could remove it and we might want to print out that object. So let's just go public object remove into position, and we pass it the position of the thing we want removed. And let's see, before we start anything, since we're going to want to return an object, we should probably just create an object up here real quick, just so we can return it. We can set it to the thing we're about to remove it, and then return it later. Okay, sorry, I had another drink of water. Okay, so we have this temp object that we're going to be returning later after we remove something. And so now think back to our add. What did we do first? We checked if it's is empty or position equals 1. These are always the special cases, but this one's going to be a little bit different. So we do have to check if it's empty. And now if they pass us, say, like if here we had, we could probably do this a little bit better in this case, because we checked if position was greater than 1, we would continue, else return false. But if is empty or, say, position less than 1, these would probably do the same thing. We would want to do the same thing here. We'd probably just return null. So we're going to return null if either the list is empty or they gave us a bad position. So this is basically the bad, or kind of like the false in here. This is what we're going to be returning. Okay. So similar to how we had a temp node in this add, we're going to have something similar to this. We'll just call it the current node, and we're going to set it to head node to start. Now we're going to have another case when we actually try and remove this head node. So if position equals 1, so we're going to want to get the object of current node. You could also put head node here instead of current node, it doesn't really matter. Get data, just so we can return it later. And then we can just set head node. We can either set this to head node.getNextNode or current node.getNextNode. Let's just do current node.getNextNode. And what this does, say we have A, B, C, D, F, you know, all that stuff. What we're basically doing is we're taking this head node and we're setting it to what it references, what it pointed to. So we're basically setting A, since it pointed to B, we're just setting A to B, so we're pretty much just erasing it. And that's exactly what we wanted. And it'll be similar down here, but there's going to be a little bit different stuff we'll have to deal with. So we did this if, so now we have to have an else. And by the way, this doesn't need an else, of course, because we're returning null, or we're just going to continue if we don't. Okay, now similar to the add, we're going to have to reiterate through it, and we're going to be using the same logic. Okay, and each time we're just going to be getting next node. And then similar to the add, we also have to check to see if it was this case that jumped out of this for loop. In which case we'd have to return null, because they asked us to remove something with a position that was outside of the max. And we could also, instead of doing this, we could say maybe in here, we could check if position is greater than get length, since we're going to have this method. That's another alternative to doing this. So there are many different ways that you could implement this. I'm just going through mine, and hopefully it works, and you know, all that stuff. So, okay. So now, remember what we did here. We have to get the object before we actually remove it, or it'll be gone forever. So temp obj equals current node dot get next node dot get next node node dot get data. because we did position -1, we have to do the getNext node to get the stuff that we're actually going to delete to get the data, because if current node is, say, B, we're actually trying to delete C, so we have to get the data of C. I'm going to move this down here. And then this is going to get a little tricky, so I'm going to write it out and then explain it. So current node dot set next node, current node dot get next node dot get next node. So here, say we have this C. So what we're going to be doing, I'm going to have a bajillion of these everywhere. So say current node is B. So we're setting the next node of B to equal the current node dot get next node, which is C's next node, which is F. So we're effectively removing C, which is what we wanted to do, by just doing a little bit of tricky things with the get next and set next that we had written in our node class. And then we're pretty much done. So we just return temp obj. Boom. And this if statement had fired, we would have returned the temp object from there or from here. Okay. And what should we do now? I guess, what do we have? We can do replace. So let's shrink this. Continuing to ignore get length. Public bool replace, and this says a bool similar to these. And position object new entry. And the first thing we're going to want to do is similar to this, so why not just copy this? Change this to false. There we go, I don't even have to write that. Maybe you could even, if you're feeling a little crazy, you could write a little method that does this, and you just call the method rather than using this code over, although it does change slightly whether or not you're returning bool or object. But similar to the remove and add, we're going to have node current node, head node. You can see this gets kind of repetitive, and once you get the idea, you could probably write more. Int I equals 1, I less than position. Now, you see what I'm doing here? I actually started at 1 instead of 0. And that's really, I mean, you can do that if you want, but it doesn't really matter, because 0 is never really going to work at all. Because, or rather, if I do it like this, then I would need this position -1. It's not really that 0 would never be used, sorry. So I could change this to 0 or this to position -1. It's really whatever you want to do. I'm just going to keep it like this, because, hey, we can have different ways to do things. We can do whatever we want. So, similar current node equals current node get next node. And then, so after we've gone through this how many times for position that we need, we will know that we are now at the node with the position. We're now at the node that is at this position, so that we need to set this data now. So current node, set data, cool method that we created earlier, entry. Boom. Return true. Very simple. Okay. What next? What next? Get entry. And at this point, you're probably like falling asleep because you don't want to see the rest of these, but I'm going to do them anyway. It's going to make my video really long, and I'm probably not going to actually test all these at the end, but you can test them. You can figure out if I've done something wrong, and you can yell at me. And I'll probably be like, you are so much smarter than I am. Similar to before. Again, very similar to before. If you're ever stuck, you can probably look at one of your previous ones you've created. And let's just set this actually to head node that get data rather than null. And this is similar to this remove. We kind of need an object because we're returning an object. Okay. Now, let's keep it. Let's use 1 this time again. Position, and remember we're going to have temp does not equals null. And I++. The reason I assigned it to this because this would fire right away and we don't want that. And I'm pretty sure I did the same thing here. Oh, I had current node, so that is another way you could have done it there. Surprising that I'm skipping around so much, but just to show you all the different options. Okay, that's looking good. And okay, so now we just want to get the next, current node. Get the next node, because we just kind of want to go through the positions. And alright. So then we want to check to see if, actually this is bothering me. I don't know why I did that. So we're going to fix this. So current node does not equal null, and then if current node equals null, turn null. Okay. And also in here, we're going to be getting the next node, but we're also going to want to we're going to want to get the data here. So we check to make sure it isn't null, so we know that this is good. So we should probably do if current node dot get data. It's always good to check. Actually, screw this. We can just return current node dot get data. So what'll happen if this is null? It'll return null, else it'll return the actual thing we want. So this works. Good, 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 good. We do the same way of iterating through that we did before, and once we've actually reached our position, all we have to do is return the data of it. Cool. Okay, what next? What next? Looks like we have contains. Contains. Okay. This is pretty much the same as the other ones, but and I'm setting this entry rather than new entry because, hey, it might actually still be in there, or it might actually exist in there. So again, current node equals head node, and this one is going to be a little bit different since we don't have this position to iterate through with the for. We have to go through every single one, so we're gonna have to use a while loop. And we're just gonna have a current node does not equal null, so while we continue to go until the very end of the list. So this might take a while if it's a really big list, which is why other data structures are a little bit better for this. We'll have to check to see if the current node, the data of the current node, equals the entry passed, then we'll know it contains it. You get that? Alright, and if it doesn't, then hey, we're just going to get the next node. And if this true had never actually fired, this return true, we're just going to return, it'll hit this return false, which means it doesn't actually contain it. Boom. And clear. Ooh, clear. So difficult. So difficult. Let's see. Do we really even need a bool for clear? Nah. Because it's always going to work. Okay, so think about this. You have this list with all these different things. How are you going to have to iterate through and delete all of them? Oh, wait a second. A references B, which references C, which references... So head node is the first one. It just references everything else. Just set it to null. That clears everything. So there's no longer anything else in the list. Do magic. No, actually just pretty simple stuff. Okay, now the lonely get length that we've kind of neglected. Okay, so let's just have a counter set to 0, and this is pretty much the same thing as contains, but we're just going to keep a counter going. The same thing as in we use a while loop. Okay, and we're going to be current node equals current. So we get the next one, and we also increment count, sorry. And at the very end, this while loop will jump out because current node will equal null, and at that point we want to return count. Boom. And that is all the methods I can really think of right now. I mean, this is a bunch. We did a lot. Yeah, my time for my video is probably very large. But we have our node. We have our linked list that we implemented from scratch. So this pretty much works like the other one. And linked list ll equals new linked list. Cool. ll dot. We have our add clear contains get entry blah 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 is full is empty. So I could write out a super complicated test case, but you know I'm kind of lazy, so let's just do a few. I'm just gonna copy this. So this would print out false, or I don't know if it prints out false or 0. And then we're gonna add, and notice, ooh, that's cool, right? That's the whole overloading, I don't know what it is. So just add that, and then let's write entry 1, and oops. And then what else do we got? We got remove, maybe replace. So replace 1 with ASDF. So this ASDF will turn into ASDF. And then let's remove it. And that will return an object which we will want to print. And I'm not sure how this whole printing will go, but we'll see. Hopefully this will work quite well. Or crash miserably. Okay. So we printed out it's empty, true, added S, got the entry 1, ASD, replaced it, printed it out, removed. So it looks like it's working. And you can mess with this, you can create some crazy program with it, just have a bunch of fun. And that's the end of my linked list. Hopefully I can do a few more of these data structure tutorials. And that's it. If you'd like to know anything else about Java, C#, C++ too, because I've learned that, hooray, or anything else that could look cool on my channel, make sure to leave a comment, subscribe, send me a private message, go to my website, anything. And that's it. This is Quackware signing out.